Let us study about transformer. A transformer, it is a stationary device used to transform electrical power from one circuit to another without changing its frequency. Okay, so we'll study this is a definition here. We'll go this picture and we'll understand better. Okay, so let's see types first. Okay, we say step up transformer and step down transformer. Okay, you can see that outside our houses and all on the roads we'll have the transformers now, big devices. Okay, so those are transformers. So there are two types in that. Okay, first one we said step up transformer. Okay, that we don't see commonly. It's used in the near the power stations there. Okay, what it will do, it will change a low voltage into high voltage. Okay, low alternating voltage AC current voltage into high AC voltage. Okay, then step down transformer that we see common in the roads. Okay, it will change the high voltage into low voltage. Okay, so these are very useful here. Okay, let's see the parts about the transformers now. So let us see the transformer parts now. First, this is the transformer core. Okay, this part is the transformer core. We'll learn the construction also now. Okay, then it has two coils there. On the left side we have the primary coil. Okay, this is the primary coil. On the right side we have the secondary coil. Okay, remember the Faraday's second experiment, same one only. Okay, that we use here. Now the primary coil has a NP turns here. Okay, it has number of turns, it has NP. Number of turns of primary, that is NP. Then number of turns of secondary we say that is NS. Number of turns in the secondary. These are turns here. You can see, okay, the number of turns of primary is less, but the number of turns of secondary is more. So we say it's a step-up transformer. Okay, we'll come to a little later about this. Okay, and the voltage that we give in the primary, okay, so we must give a voltage now. That we say voltage in the primary is VP. Okay, and the voltage that we get across secondary we say it as VS. The voltage across the secondary. Okay, so and this is a primary winding we say, and this is a secondary winding. Okay, so now we know about the construction here. Next we'll see how it works. What is the working of this? Okay. Even before we go to the working, we'll first see the principle here. It works on the principle of mutual induction. Okay, there are two coils here, and then the magnetic field produced by the first coil will hit the second coil, and then EMF is produced. Okay, that principle is used here. Mutual induction is used here. See, I have drawn the transformer diagram smaller in the top left corner here. Okay, so let us now see about this working of this. Okay, how it works here. See, now we give a voltage here. Okay, VP, and then what happens is due to induction. Okay, there will be back EMF here. Okay, so let us see the back EMF in the primary coil here. So we'll see back EMF in the primary coil. Okay, so the back EMF we write as epsilon. Okay, in the primary, back EMF in the primary, that will be equal to, we use that Faraday's law here, then we get here minus NP into d phi b by dt. Okay, so this is a from the Faraday's law. Okay, actually n will come here, we are taking out. Okay, and minus n is due to Lenz's law. Okay, now if you see this back EMF is equal to this voltage that we give. Okay, so right here this side, so voltage in the primary will be equal to the back EMF. Okay, this is done by using experimental form. Okay, so the voltage in the primary will be equal to minus NP into d phi b by dt. Okay, next we see what is the EMF in the secondary. Okay, so in this thing also there will be EMF there now. Okay, so that we'll study now. So EMF, that's the back EMF in the secondary, coil. We'll study now. Okay, that back EMF in the secondary coil, that is ES is equal to minus, same way we have NS into d phi b by dt. Where phi b means what? The magnetic flux. Okay, the magnetic field produced by first conductor. Okay, it will go hit the second conductor. Okay, and that is why it will cause of EMF here. Now this back EMF in the secondary coil is equal to the voltage in the secondary coil. Okay, so that we will write here now. Okay, so voltage in the secondary coil, that's equal to this one minus NS into is equal to sign. Okay, minus NS into d phi b by dt. How it happens is because the voltage in the secondary is equal to the EMF in the secondary. Okay, next we'll see. So we'll take this this one as equation 1 and this one as equation 2. Okay, so divide equation 2 by 1. Okay, so divide equation 2 by equation 1. Okay, let's divide and see what we get. So we'll take equation 2, that is Vs. Okay, that's equal to minus ns into d phi b by dt. Okay, divide by equation 1. Okay, what's equation 1 here? That one. That's Vp is equal to minus np into d phi b by dt. Okay, so what happens is minus sign cancels here, d phi b by dt cancels, d phi b by dt cancels. So we get here Vs by Vp is equal to ns by np. That means what? Voltage in the secondary divided voltage in the primary is equal to number of turns in secondary by number of turns in the primary. Okay. That means if we have more turns in secondary, what happens? We'll get more voltage in the secondary. Okay. Now this will be equal to a constant here K. Okay. This constant we call as a transformer ratio. Transformer ratio. Okay. This is a very important relation here that we must know. Okay. Next, let me rub the left side. Okay, so let's now see the power here. Okay, what happens to the power here? So we give a power into this one. Okay, the primary coil. The same power must come out also. Okay, so we can say it's an ideal transformer. We say okay, the input power will be equal to the output power. Okay, output power. So power means what? Voltage into current. Okay, V into I. That will be equal to V into I, but you must write this one, voltage in the primary into current in the primary. Okay, that's equal to voltage in the secondary into current in the secondary. Okay, this is what we get. So this one we know. Okay, next we'll see in terms of amplitude. Okay, that we'll write now. So in terms of amplitude, okay, and we will see the current also. Okay, we got this equation now. We'll write this in terms of current also. So we get here Vs by Vp is equal to Ns by Np. That's equal to, but you must see the current now. Current will be Ip by Is. Okay, so this will reverse here. Okay, see the terms here. Okay, Ip. This is all things are S here, only this is P here. Okay, so this is very, very important. Okay, so this is in terms of amplitude here that we get. Okay, next we'll see what is meant by the step up and step down transformer. Okay, now let's see the step up transformer. So this is the step up transformer. You will draw it one more time. Okay, draw this down. Then you can see this first one in the case here. Okay, if the number of turns in the primary, okay, you see, okay, number of turns in secondary, sorry, number of turns in secondary, okay, this is more than the number of turns in the primary. You can see that there are more number of turns in secondary than in the primary. Okay, that is if the K is greater than 1. Okay, so this transformer ratio is greater than 1, and then you see what will happen, the voltage in the secondary will be greater than the, so we came up to here only, the voltage in secondary is greater than the voltage in the primary. Okay, let's see the currents here now. Okay, the current in the primary we say it as Ip here. Okay, see the picture here, Ip. Current in the secondary we say it as Is. Okay, so current in the secondary will be less than the current in the primary. This is very, very important. Why? Because the product of voltage and current will be constant here. Okay, so input power and output power will be constant. See symbol here, less than. This is all greater than, only this is less than. Okay, so next we'll study what's meant by a step down transformer. Okay, so what's a step down transformer? Okay, so in step down transformer, okay, we have a core here like this. Okay, so input number of turns, that will be more. So number of turns in primary is more, and the number of turns secondary is less. Okay, so this is about the step down transformer. Step down, what will do? It will change high voltage into low voltage. Okay, and step up will change low voltage into high voltage. Okay, so let's see what does it do. Step down transformer. Okay, so number of turns in the secondary will go as it is in the order will go. So number of turns in secondary is less than the number of turns in the primary. You can see it from picture. Number of turns in secondary is less than number of turns in the primary, and the voltage in the secondary, okay, will also be less than the number voltage in the primary. We say step down. Okay, so voltage in secondary will be less, and now you see current here. Because voltage is reduced, current will increase. Okay, so current in the secondary will be more than the current in the primary. Okay, and this Ns is less than Np now. So we can say K, the transformer ratio is less than 1 here. Okay, So this is about the transformer scheme. Next we'll study about the efficiency of the transformer. Let us study the efficiency of a transformer. Efficiency is eta. Okay, so this symbol, okay, it means eta, ETA. It's a Greek alphabet. Okay, that's how to say that. Now, eta is equal to output power by input power into the 100%. Okay, this is the formula to find the efficiency. So efficiency eta ranges from 96 to 99%. Okay, you cannot get 100% efficiency. Why not 100%? Why? Because due to various losses there. Okay, so in transform there will be various losses. So whatever power we give, okay, the same power will not come outside. Okay, so input power will not be equal to the output power. There will be some losses there. Any kind of transform will have like this way. Okay, so let us now see what are the various losses in a transformer.